today we are going to explain you about our project Automated Signal Indicating System for Level Crossing. My name is B. Nitish Kumar Balga and my teammates are Rajwal VR, Samprit PK and Mohammad Faizan. Before we directly dive into our project, we'll see what a level crossing is. A level crossing is a point where a railway track intersects a roadway. As per the record, almost 41% of the accidents in Indian railways happen at level crossing. To minimize the accidents at level crossing, we have taken the project. Also, Government of India and Ministry of Railways are planning to eliminate all the level crossing and construct a road overbridge and road underbridge over this level crossing, thus by smoothing the road traffic and rail traffic. The description of this ROB and RUB, that is road overbridge and road underbridge, will be given by Mr. Samprit PK. As we all know that construction of ROB, that is road overbridge and road underbridge, is not an easy task and may require lot of time, and also the finances included are very much high. So we have come up with an idea of including a signal system which gives the signal based on the location of the train. That is, when the train is near the level crossing, there will be an audio message and a visual message informing the road user that there is a train approaching. So be careful while crossing the level crossing, or please wait for a while till the train crosses the level crossing.
I am going to discuss about the references survey. Firstly, regarding the gate and the locking arrangement. Gate, it may be in the form of the chains, lifting barriers or movable gates, and the locking arrangement may be the lifting type barriers, gates, or chains when pressed against the road causes traffic shall be blocked securely. Now, the disadvantage of this gate and locking system is that it takes a considerable amount of time for the gateman to proceed, as he has to follow certain procedures, and this is the waiting time and the traffic increases. Now, ROB and RUB, which is seen as a solution for this, that is the road overbridge and the road underbridge, and the railway has a budget of 64,000 crores for the year 2019-2020 for construction of new lines, doubling of the tracks, and the gauge conversion. But the problem with the ROB and RUB that we have seen is that when we visited the Jokatte level crossing, it is seen that government gave a sum of around 10 lakhs for the residents for the construction, but the residents are demanding in excess of 10% more. So this causes a financial constraint, and as such the construction has been stopped. And in order to reduce the percentage of accidents near the level crossing, government has taken initiatives such as SMS like campaigns, natakas, so as to educate regarding the railway traffics. Now, the other system that has been followed that is the RDSO, that is the Research Design Standard Organization, has taken initiatives such as TAWS, that is the Train Activating Warning System, to warn the passengers. And the IIT has formed a MOU with Indian Railways to form a prototype using a radio frequency warning system, which has been currently been used near Lucknow. And regarding the methodology that we have been used, firstly the location of the train has been located using a sensor, and as soon as it crosses the first sensor, a red that is a danger signal will be shown to the pedestrians or the people who are crossing the level crossing for them to stop. And as soon as it crosses the second sensor, that is the green signal will be shown, and the passengers, the pedestrians and the vehicles can cross the level crossing. This is the system that will be used. This will be shown using a prototype by Mr. Rajwal.
Part of our literature survey, we have visited 3 level crossing gates before the lockdown was imposed. The gate numbers are LC gate number 90/300-400, which is at Jokatte, LC gate number 135E, which is at Arpula, and LC gate number 79, which is at Kundapura. The observations that were made by my team were the common operation when the gates are closed and when the gates are opened. The common procedure followed at all these 3 gates are: when the train approaches the station master calls the gateman via an interlinked telephone, and when the station master notifies the gateman that there is a train approaching the level crossing, a gateman closes the gate and notifies the station master, and there is an exchange of private numbers which acts as a proof that there has been a communication between the station master and the gateman. When the private number is exchanged, the station master will display a clear signal to the train, and the train will move on to the next location, crossing the level crossing gate, thus thereby ensuring a safety of passengers, road passengers as well as the rail passengers.
So introduction part was very well done by my friend. So now it's my duty to explain you about the 4 different cases of level crossing for a project which we have planned. So I'm going to explain it in detail. So this is the case 1. So in this case 1, this is the railway track and this is the level crossing. So the case 1 is the level crossing is at a distance of 1.5 kilometer, more than 1.5 kilometer from the station 2 and more than 1.5 kilometer from the station 1. So in this case we will be placing a sensor at a distance of 1.5 kilometer from the level crossing. For example, we will be placing a sensor over here and a sensor over here, that is 1.5 kilometer from the level crossing. So whenever the train leaves from the station and reaches the particular point, that is where the sensor is placed, so the train will be detected by the sensor and a red signal will be displayed over here at the level crossing. So when the red signal will be displayed, the traffic will be stopped and the train will be moving, and when it reaches over here, the sensor will detect the train and the green signal will be displayed. At that time the traffic will be cleared. This is the case 1. This is the case 2. So this is the railway track, this is the level crossing. So in the case 2, the level crossing is at a distance of less than 1.5 km from the station 2 and less than 1.5 km from the station 1. So in this case we will be placing a sensor approximate like 650 to 750 meters from the level crossing. For example, we will place the sensor over here, that is 650 to 750 meters. So whenever the train will be crossing over the sensor, the train will be detected and the red signal will be displayed. And whenever the train crosses this sensor, the train will be detected and green signal will be displayed so that the traffic gets clear. So this is case 3. So in this case 3, this is the railway track, this is the level crossing. So the distance from the level crossing to the station 2 is more than 1.5 kilometer and the distance from the level crossing to the station 1 is less than 1.5 kilometer. In this case, the sensor will be placed, that is for less than 1.5 kilometer, the sensor will be placed like here, that is 650 to 750 meters from the level crossing. And for more than 1.5 kilometer, the sensor will be placed at 1.5 kilometers from the level crossing. So whenever the train will be moving, the sensor will detect the train and it will be showing red signal at the level crossing. At that time the traffic will be stopped, and when the train moves continuously and when the train reaches at this particular point, the sensor will detect the train and it will be showing green signal. At that time the traffic will be get cleared. This is the case 3. So this is the case 4. So in the case 4, this is the railway track, this is the level crossing. So the level crossing is at a distance of less than 1.5 km from the station 2 and more than 1.5 km from the station 1. So in this, which is at less than 1.5 km, a sensor will be placed at 650 to 750 meters from the level crossing. And for more than 1.5 km, sensor will be placed at 1.5 km from the level crossing. So whenever the train crosses the track, when it reaches at a particular point, the sensor will detect the train and a red signal will be displayed so that the traffic gets stopped. So after the train reaches at this particular point, the sensor will detect it again and it will be showing it will be displaying green signal so that the traffic gets cleared. So these are all the 4 different cases. So the execution part of this 4 different cases will be explained by my friend Rajwal. Thank you.
I'll be explaining about our project using a simple prototype what I have done. This is the prototype of our system, which includes Arduino Nano, 2 ultrasonic sensors, and signal indicating system. When there are no trains near the level crossing, the signal indication system will be a clear signal which is green, which means that road vehicles can cross the level crossing without any problem. When the train is arriving the level crossing, imagine this as a train. When it passes the first sensor, the signal will be automatically turned to red, which is a danger signal. That means road vehicles are not allowed to cross the level crossing. And we can see in the serial monitor that it shows train arriving the level crossing. And when the train passes the second sensor, the signal will be automatically turned to green, which is a clear signal. And also in the serial monitor it shows train past the level crossing. The distance of both the sensors from the level crossing is explained by Faizan while explaining 4 different cases of level crossing depending upon the station location. Coming to the conclusion part. In this lockdown period, even though we could not visit most of the places we planned of visiting, we have gone through different manuals that are published by Indian Railways, and we got a lots of information from those. And we also contacted some of the railways executive, and they were explained about our project. And they were also asked to give feedback about the execution of our system in real life. And we got a good positive response from them.